welcome to this next installment of SurveyCTO's webinar series. My name is Amrik. I am our Director of Customer Success. And in this webinar series installment, we're going to be looking at sensor-powered quality control. However, just briefly, for anybody who doesn't know how to answer the question, why SurveyCTO? SurveyCTO has powerful form design features that lend themselves to flexible and scalable deployment in any data collection setting. The result is robust form designs, facilitated partly through features for testing form designs to help you with quality control. Innumerable complex form designs and workflows are possible as required. Quality and trust are design principles in the product, with sophisticated quality control functionality. Enabling the review and corrections workflow allows you to take advantage of automated statistical checks as well for flagging records. Powerful real-time data monitoring and visualization tools are built in while facilitating data publishing to help you take advantage of the features of outside systems. Data protection is also a key design principle, with multiple layers of security built in, including optional end-to-end private public key encryption, single sign-on, and restricted access through the use of custom user roles with teams. SurveyCTO also offers GDPR compliant hosting. The platform is also supported by a team of experts who are constantly improving a growing body of knowledge, which will help you get started with SurveyCTO, including a self-paced training course. Okay, so what will you learn in this webinar? We'll look at what sensor statistics are, what these sensor readings look like, and how you can use them to improve the quality of data. This is something that we have written about before. I shared a few links to existing resources, the one of which has an accompanying sample form, which is also important for getting started with sensor-powered QC. So what are sensor statistics? Mobile devices have different sensors, including GPS, gyroscope, microphone, light sensors, a linear accelerometer, and other types of sensors. A gyroscope and a linear accelerometer are special sensors for measuring movement, if you're unfamiliar. Gyroscopes can measure rotation, whereas a linear accelerometer actually measures and estimates movement of the device through space along an X, Y, and Z coordinate. And we'll have a look at that just now. A stream of sensor readings are recorded and observed by the Android operating system. And depending on the mobile application, these applications can also see this data. Unfortunately, sensor stream statistics are not yet supported by our iOS app, so just keep that in mind. SurveyCTO Collect on Android can record these streams of data and also summarize them as useful statistics per form submission. And this is along the lines of convenient statistics that we have for you around light, sound, and movement. Just keep in mind that older devices or more budget-friendly devices may not have every sensor, and those sensors may not be equally good in all cases. So what do sensor statistics data look like? Well, I have prepared a video recording to show you, just to talk you over a little bit of what these look like while you're collecting them. I've recorded this video using an Android app which is free called the Physics Toolbox Suite. So this is not what you'll see inside SurveyCTO Collect. While collecting sensors, sensors are invisibly recorded in the background. But anyway, let's take a look. Okay, So what do these look like? First of all, movement is recorded by a sensor called the linear accelerometer. Linear acceleration is measured by looking at movement along an X, Y, and Z axes, and that's aggregated to a total acceleration score. And you can see the total acceleration soaring here as I'm moving much faster, and then it drops down to a much lower value. The next sensor we'll look at is light, measured by your light sensor. Here you can see the light value. It's around 5,000. It's dipping now, closer to 1,000. So around 1,000 is an overcast day, and you can see here it suddenly maxes out at 10,000. Clearly the sensor in my device is not that flexible. Sound volume, which is measured by the microphone. You can see this sensor reading being recorded here. The value rises quite high here. I found that my microphone is quite sensitive. Sound pitch is also measured by the microphone. So here I just spoke into the microphone to get the hertz reading, and this app also tries to give you the musical note as close as you can find it. So that's a little bit of exposure to sensor metadata. Okay, so we've had a look at the video now. We're going to look at some of these values, what they mean in a bit more detail. So first of all, with light. Light is measured in a unit called lux. Around 300 to 500 lux is approximate bright-ish office lighting. 1,000 lux is an approximate overcast day, and a sunny day can be as much as 10,000 lux at points. Movement is measured by the linear accelerometer, and linear acceleration is meters per second squared. So again, this is an aggregation of measurements along an X, Y, and Z axis. And in our testing, approximately movement looked something like 2.73 meters squared per second. Sound volume, measured by the microphone, is measured in a unit called decibels. So some examples, 20 decibels is a whisper approximately, and 120 decibels would be live music at a festival of some sort. Sound pitch, how high or low the sound that's being observed or detected by the microphone, is measured in a unit called hertz. 85 to about 180 hertz is the approximate range of the human male voice. Lastly, while not a sensor reading, SurveyCTO provides a few sensor statistics, including the conversation statistic, which is an attempt to estimate the percentage of time a conversation is taking place around the device. Now, this is an experimental feature, so it won't be right all of the time, but it's one of many flags for you to look at problems like the rest of the sensor statistics. So moving on. How are sensor statistics helpful? Well, sensor readings of a device will vary depending on how the device is used and its environment. So for example, in a loud place, the microphone will pick up loud sounds. And if the device is used outdoors in direct sunlight, high levels of light should be detected. So the sort of small conclusion here is that when a sensor statistic deviates from an expected range, that might mean that you should look more closely at a form submission. But how do you know what a good or bad sensor statistic value is? Well, it's an important question, but it's not the easiest one to answer, but we'll look at this. So, option one, you might choose to profile the activity that you want to measure with statistics during a survey pilot to establish a baseline for each of the sensors for light, movement, and sound, and use that to establish thresholds to look for problem submissions. Alternatively, you can trust in statistics to flag outliers. Use automated quality checks to flag records for assessment in the review workflow. So these two options are also not mutually exclusive. Option 2 can be used to reinforce a better version of option 1. You can use statistical outliers automatically identified by our software to help you determine the correct threshold. But in general, what we're doing is we're looking for outliers. But hang on, what is an outlier? Well, let's just clarify this for the sake of our webinar. Over time, after collecting enough data, a distribution emerges with more frequent and less frequent values. This data won't always be normally distributed in the way that you can see in this graph. Some values will stand outside the distribution, so they might be very low, very high. Also, it's important to realize not all outliers are an indication of a problem, or that it's not incorrect or bad data. So an example with another non-sensor data type is that a household size of 20, when the average household size is 4, stands out. It's a bit strange. So that's definitely something that you would pay attention to otherwise. More on outliers. In our proposal to you, we're suggesting that you use the interquartile range of a given value to identify outliers. The interquartile range is the middle 50% of values in a dataset, excluding the lowest 25% and the highest 25%. You can arrive at this statistic by subtracting the first quartile from the third quartile. The interquartile range is a measure of variability or spread of the data. So as part of our suggestion to you, we'll be flagging sensor statistic values that are outside 1.5 times the interquartile range. So covering actually the middle 75% of values. So it's not quite as sensitive. So what do sensor outliers tell you? Well, that's a good question. It depends. You are unlikely to be able to automatically flag submissions. Sometimes sensor readings will be different for good reasons, which you might be able to work out. For example, low light levels because an interview ran late into the evening, or very high sound levels because the respondent's home was being renovated. Sometimes sensor readings will indicate problems like deviation from procedure, or in the worst of cases, made up data. So, for example, sensor statistics indicating that somebody sat indoors in total silence when a conversation should have been happening outdoors. Sensor statistics can help direct your attention towards potential problems that you might have missed otherwise. So why else would you use sensor statistics? Well, the other good reasons include that sensor statistics are not personally identifying. So even in fact, the experimental conversation statistic doesn't really identify anybody. There's no recording. It's just a measurement and an analysis of what that sound is when it's being detected. So there's no consent that you need to involve to collect this data. So it's simple for IRB processes. There are generally no ethical considerations. And so you can actually freely share this data with any partners who are interested, which is something I'll talk more about later. Also for Stata users, we have a command for easily summarizing sensor stream data, which will allow you to generate statistics after data collection has completed, as opposed to the summary statistic that sensor statistics provide. So that's something to keep in mind for those of you who work in Stata. Okay, hopefully I've made a reasonable case for collecting sensor statistics. Hopefully I at least have some of you interested enough to try. But how do you get started? Well, that is a great question. So you may already have a form that you want to collect data with. So you could update that form's design to capture census statistics. We happen to have a sample form that contains our recommended census statistics. You can copy those fields directly into your form design, and you can find that in the first link. With the form design deployed, we recommend setting up automated quality checks based on that sensor data to flag submissions based on sensor outliers. We also recommend that you enable the review and corrections workflow and set it up so that records get flagged based on automated quality check warnings. So with your form deployed and the server console set up, you can start to collect data. And during the process of collecting data, you can explore and discuss the census statistic data that you are generating. And we encourage you also to include your field staff in these conversations. You may come to better understand what different values could mean through broadening that discussion and including the field team as well as your office teams. Okay, so we've come to the point in the webinar where I'd like to show you some things in practice. I've made this demo checklist just to keep myself on target. So we're going to have a look at that, at the sample form that was used to collect the data that we'll be looking at. We'll review the automated quality check creation process, and we will review the review workflow configuration. And we'll also spend a few minutes looking at some sensor statistics inside the Data Explorer. So I'm just going to exit the full screen presentation because I would like to show you some of my other tabs. So to start with, we are going to have a look at the form design. I'm not going to discuss this in a lot of detail. You can look at these sensor statistics in the form that's part of our sensor-powered quality control article in the support center. They're exactly the same fields. So I have some non-sensor audit fields here as well, which are generally a good idea. And also this bank of sensor statistics fields. I've got sensors recording mean values, standard deviations, also percentages, like the percentage of time that a device was still and the percentage of time that space around the device was quiet. Also the conversation statistic. Just briefly about the context of this form. This form involves a fictional data collection scenario. Enumerators went into villages, asked consent, so there's a conversation taking place. They ask some demographic questions, as well as the crop they grow, and then they measure the size of a plot owned by that respondent. And depending on the size of the plot, they either get included or excluded for some sort of program. Okay, so that's enough about the form. The important things to take from this are that we're expecting to see a conversation for a good amount of the time, and we're expecting to see movement. And also this is an outdoor activity. We're measuring what's happening outdoors, so we should ideally be seeing high light conditions as well. Okay, so that is the form design. Okay, on to our SurveyCTO server console. So we are going to want to work on the monitor tab of the SurveyCTO server console. So I'm going to open monitor and scroll down. So first, we're going to have a look at automated quality checks. Some of you may be familiar with these already. I already have one check enabled, but we'll go over the creation process just quickly. So to create a check, I clicked on checks, and now I'll click on create quality check. Also keep in mind that the automated quality check section needs to be enabled by an administrator on the server. So if you don't see this, speak to the admin on your server. So, okay, let's get started. Create quality check. So the different types of quality checks, I will be going with the value is an outlier quality check. These other types of checks are also discussed in the product documentation. So please do check out the documentation on quality checks, but this one is a check to check every single record and warn for each one that has a field value more than X times outside the interquartile range. So a quality check can run on more than one field. For example, I've just selected 3 sensor statistic fields. The check I already have runs on all of my sensor statistics. And the check will run on each sensor independently, as though you had set up the same check with each of those sensors with the same settings. So only light or mean light values will be considered when flagging records as outliers because of their mean light value. So you'll click next. So most of the time you can just click save here. But if you do want to alter the interquartile range value, you'll use the advanced options menu. So you could increase that to make it less sensitive, or decrease it to make it more sensitive. Okay, so that's quality check. So I'm just going to cancel this because the one I have already is doing the job that I want. Okay, so the review workflow is also something you'll want to configure. It's already set up for me, but you'll click on the review workflow option, and you'll click on the toggle button to enable it. It already says yes here, so mine's enabled. So the thing to do is to flag some records. Some of those records are being flagged in response to quality check warnings. So I've enabled all of the options for quality check warnings. You can be a little bit more nuanced in your choices. And we also strongly recommend flagging a random percentage of submissions for individual review. So in this case, that random percentage is 20%. Okay. There are also some other discretionary settings which you can read about in our product documentation on the review workflow. We also have some videos in our video library which will be helpful for understanding this if you're not familiar. So the result of the settings of the review workflow results in alerts like this one, which will take me to the form, and messages like this: new data awaiting review and approval. So I can, if I wanted to, click review now and start individually reviewing submissions. This is how it would normally work, but I actually want to show you this more in context, more as part of the distribution of data. So I'm going to close this for now. What you want to do is monitor the data if you're doing what I'm doing. So with all submissions selected, you would start the Data Explorer. So I've already done this just to save a few seconds. We'll take a look at the next tab that I have open. So the Data Explorer, if you're unfamiliar, is really user-friendly. It will open with none of these summaries, but if you want to open or create summaries, you'll click on the plus button to add a summary or group. You'll click on the button to add field summaries. You'll click on the check mark next to the name of the fields that you want to summarize, and you'll click Save Now. And summaries like the ones that we'll look at now will load up. But I have all the summaries that I need, so I'm going to click on Cancel. So I'm not going to interrogate these higher up summaries. Rather, we're going to look more closely at the ones to do with the census statistics. So the first one we'll look at in our series of examples is the mean light level. There are no recent quality check warnings at the moment down here. Also, we can see that the mean light levels are actually very variable. We have some super high values, the highest being almost 6,000 lux, and the lowest, concerningly, being 0. You can see there are lots of levels aside from that, but perhaps most concerning, the most frequent range is this 0 to approximately 570 lux. So that actually suggests that this bin of interviews is actually taking place indoors, which is probably concerning and something you'd want to look into. But let's, as an example, just look at this this value, or this submission with 0 for mean light levels. That seems very strange. So when I click on the minimum value, I can view that submission. So while there were no warnings for this particular submission for mean light levels, this particular submission is still an outlier. So you can see when the report was run at this time, and this is for the percentage moving statistic. The value in this case is 0.4, which is below the interquartile range, which ranges from 0.67 and change, and 0.854 and so forth. So in other words, the percentage of time that this record was moving was lower than expected. So I don't know, maybe the enumerator was dawdling and walking a bit slowly. It's possible. So let's explore a little bit further. All right, so this is also something that's obviously important to pay attention to. The record is only 20 seconds long, so that's not a census statistic, but it's generally something you want to pay attention to. Okay, so here again, light levels 0. It's really hard to know what was happening there. Was the device in the enumerator's pocket? Was it pitch black at night? Although even moonlight should be recordable to some degree, so maybe there's even something wrong with the device being used to collect data. So the mean movement value here is also a bit slow compared to our understanding of sort of average movement value for walking around. The sound levels, that's around the level that you would expect for conversations. And you can see that the percentage conversation statistic is 0.7, so 70% of the time. Most tellingly, though, consent was no. So perhaps as the survey manager, you're a little bit less interested in this record, but you may want to investigate the fact that the light reading was 0, because if the enumerator continually gets 0, there might be something wrong with the device, and maybe that's something you can intervene with in future. Okay, so we've looked at this submission. We are going to move on to another example. Okay, so I'm going to skip this next one for the mean movement. So what are we looking at here? This time around, there are some current warnings. Now, that's something to keep in mind. There were older warnings at a point based on the older distribution of data, but as more data gets submitted, the distribution changes, and what is an outlier will also change. But that's something I'll also chat about a little bit later. So our median value is 2.73, our approximate walking pace, or so our testing suggests. The maximum value was 14 or almost 15. I'm not sure if somebody was sprinting. And the minimum value was 0.48. Actually, I believe I can tell you that no one was sprinting. I did some testing with my devices, my test device, moving it back and forth in my hands as I walked, And that seems to result in larger movement values. But let's take a look at this first submission. So I'll click on the View Submission button. Okay, so not only is this an outlier for mean movement, also for the standard deviation for movement. For anybody who needs a refresher, standard deviation is a measure of dispersion, the distance from the mean. So in other words, a high standard deviation value means that the score in this case was quite far from the mean, and in this case it suggests lots of variation in movement. So that's not necessarily a problem by itself. Anyway, let's look a bit further at this record. It's about 4 minutes in duration. Our light levels suggest that work took place outdoors, which is good, but it's also very variable light. But even on the low end, thinking about the standard deviation, that still suggests the light that things took place indoors. Maybe it was an overcast day, or there was lots of tree cover, providing lots of periods of more and less light. Sound levels were quite high or approaching high, but still a conversation might have been taking place just looking at that by itself. But whatever the sound was, it was very constant. The standard deviation level is quite low, so this would have ranged in practice very little around 75. Our conversation percentage is only 0.2. So maybe there was just a small conversation before measuring the plot. Also, if you happen to be using other audit fields like the audio audits, you can always listen to those recordings. And I happened to listen to this before, and what I discovered is you can actually hear the wind just hitting the microphone. So, and there's actually no conversation taking place at all in this minute-long recording if you play it back. So that's something to keep in mind. Definitely the enumerator wasn't doing what they should have been doing. Okay, so we've taken a look at that. We're also going to take a look at the mean sound levels. So there's not a lot of variability here. The range is relatively small. So no interviews took place in very, very loud places or particularly quiet places. And there are also no current warnings for this statistic. But all the same, there is something concerning. An audible conversation typically should be happening around, let's say, 60 decibels. So this first bin, okay, it only has one submission there, but that's in the 35 to 44 range approximately. So maybe that's a submission that we want to have a look at if we haven't done so before. So I'm going to view this submission just to have a quick look. Okay, so while this submission was not an outlier for the mean sound level, it is an outlier in many other respects. The percentage moving value is a lot lower than the interquartile range for percentage moving. The percentage of time that it was quiet is also out of range. Similarly for the percentage of time still. It's a slightly longer record, as we can see here. So the mean light levels here, this is indoor lighting or evening lighting or very low lighting. It's certainly not something that's happening during the day in direct sunlight. And you could also cross-reference this with the start time and the end time to consider what's actually happening. So that might be something useful to do. The light levels were also very variable in this case. Movement is quite slow. And the sound levels are quite low. Also, this is another record where it hardly seemed like a conversation was happening. So that's something to look at. Also, because we charted coordinates using a geotrace field, you can also view coordinates as well if you wanted to see what happened. And it seems in this case, the enumerator is working inside a building, very much not working to measure the bounds of an agricultural plot. So you definitely have something to say to this enumerator. Okay, so that is our last sensor example that I want to discuss with you. So just with time in mind, I'm going to return to our presentation. Okay, so we've done our little demo. I have a few reflections to share with you. But first, a note. Remember that with quality checks, they run afresh each time submissions are made. So you'll want to look at the most recent batch of warnings. Warnings will also only start to appear after 10 values have been generated. And in general, the interquartile range will shift as new data is received by the server, altering the definition of what an outlier is. You may find, as I was saying before, that an interquartile range is maybe of 1.5 times is too sensitive. So you may consider increasing it for fewer warnings, but also if you want more warnings for a particular statistic, you might reduce the interquartile range value. In our limited exploration, our most frequent warning type for sensor statistics was from the percentage moving statistic. Maybe that was also because our data collection exercise involved walking around, whereas sitting in somebody's living room answering questions probably involves much less moving, so lower movement scores. You can also think on other types of quality checks that make sense. For example, consider the value too high and value too low check types with custom thresholds. This is more work, but every project is a little bit different, and it might help you get more useful warnings. You might, for example, through experimenting with the interquartile range, decide that really high light readings aren't actually a worry. You're worried about low light readings, so you might use value too low only for the mean light sensor statistic. Lastly, in terms of reflections, did you know that you can run quality checks on data stored in server datasets? Well, you can. You could selectively publish sensor data. For example, only for submissions where consent was answered as yes, and run quality checks on just those submissions if you prefer. You'd still want to find those same submissions in the main form data and the review workflow and make comments and corrections based on your findings. It just depends on how you want to use all this functionality, because it really is quite flexible. Can you help us? We want to build a machine learning system that can flag problematic form submissions automatically for you. The machine learning system will try to recreate the same judgments made in the review and corrections workflow by you. So we'll need a large amount of sensor data collected in real projects and categorized in the review workflow. We're looking for partners who are committed to collecting sensor data, who can help us collect data and share sensor statistics. But what do you have to gain from this? Well, we can't promise you a date by which our machine learning system will be ready from this vantage, but for long-term SurveyCTO users and anyone else seriously invested in data quality, you'll be helping to contribute to automated quality control systems that pay attention to non-personally identifying information, helping to improve the quality of all surveys conducted using the SurveyCTO platform in future. Further, if your team is interested in data science and wants to collaborate with us, we'd definitely like to speak with you. So the machine learning can help us make a tangible step towards much higher quality data for all SurveyCTO users. So for those of you who are interested in finding out more about collecting and sharing statistics, maybe doing analysis on shared statistics, I am posting a link where you can register and indicate your interest. And we will get in touch with you if you are interested in helping out. Okay, so we are now at the end of our webinar.